Application of nonlinear function in business, part 3. So now we will learn about revenue function and break-even point analysis. So revenue function is the form of the total revenue function, and that is nonlinear and generally represented by a downward opening parabola equation. Okay, like this, downward concave. And total revenue is a function of the quantity of goods, and it is also the product of the quantity of goods and the price per unit of goods. Okay, remember that TR is equal with PQ. So this one is the description of the equation. Just as the concept of costs, in the concept of revenue, the definition of average and marginal are also recognized. Average revenue is the revenue obtained per unit of goods, which is the total revenue divided by the quantity of goods. So this is, and then the description for marginal revenue is the additional revenue obtained from each additional unit of goods produced or sold, just like what I have mentioned in marginal cost from the previous part. So again, this is the total revenue. Okay, I'll change the black here. TR is equal with QP or PQ, and then the average revenue is just total revenue over Q, and then the marginal revenue is again total revenue from the next step of production minus TRN over QN plus 1 QN. Now let's go to the example. The demand function faced by a monopolistic producer is shown by P equal 900 minus 1.5 key. What is the equation for total revenue? So I go one by one, yes, until here first. Given that P is 900 minus 1.5 Q, what is the equation for total revenue? So total revenue is just P times Q, and that is, what is P? P is this one. So change that with 900 minus 1.5 Q, and then times Q. Okay, so you just change this one with this. Then this will be 900Q minus 1.5Q quadrat. So these all are the function. TR is the function of Q. Next is, what is the total revenue if 200 units are sold? What is the total revenue? So I will give the question here. Question is A is total revenue function, and then B is what is revenue if the Q is 200. Calculate the marginal revenue selling from 200 units to 250 units. C, marginal revenue from 250. Determine the sales level that generates maximum total revenue, and what is the maximum revenue amount. So TR max and Q at TR max. Okay, so we have it here first for the first question, the function of TR. Okay, so TR is 900Q minus 1.5Q quadrat. Okay. For the next question is, what is the revenue if the Q given in 200? B, like this. Okay, so TR will be 900 times 200 minus 1.5, 200 quadrat, and that is, so TR will be 120,000. Okay, let me check first. Let's check it together. 9 times, yeah, 102. There are 40. 120000. Yeah. Okay. Now, yeah, I forgot to mention about the what is the price, because in the problem is, the question is also what is the price when the Q is 100. So P, again, you can use the previous question, 900Q, 900 minus 1.5Q. This is our previous problem, yeah. Or you can find it through TR over Q, because TR is equal with P times Q. So both ways will give the same results. So if you put here 900 minus 1.5 times 200, that will give you 600, and this is also the same, or 120,000 over 200, so 600. Yeah, so that's the same. P at Q 200, right? Okay, now C. What C is, what is uh, the marginal revenue from 200 to 220, 250. So let's find first the TR at 250, because you know that MR is the delta TR over delta Q, and we need TR from 250 with TR 200 over 250 minus 200. So um, well, my former explanation about the MR is the one additional input. Now it can be modified like this problem. So the delta might be below, no below, further than 1 unit. Like this, it's a 50 additional input. Okay, so it is possible. Now we have TR 200, not 250. So we have to find the TR of 250 first. So 900 times 250 minus 1.5, 250 quadrat. It gives you 131,250. Okay, have you guys also checking that with me? Right. Now, the MR will be TR 250 is 131,250 minus 120,000 over 250, 50. Okay, 200, sorry, 200. Now this one, the result of this is 1,125. Yeah, okay. 0 minus 0, 5 minus 0, 2 minus 0, 1, yeah, over 50. over 50, that is mm, 225. So what does it mean? So um, the revenue, the additional revenue from 200 products to 250 products will give units, yeah, not products, units, will give the additional revenue from 200 units to 250 units is 225. Okay, so that is how you conclude what is the marginal revenue is. Right, now next, okay, the maximum value of TR and QM. Okay, max, yeah. So is it really max? Max means that the curve should be downward. Is it downward? Let's see at the function here. What is the A over here? From the function, from TR function, the A is minus 1.5 and B is 900, C is 0. So this A over here is negative, so it means that the curve will be downward, concave. Okay, remember about the money in your savings account? I said if it is negative, then you will cry. Okay, so it has maximum point. Now, QM, because Q is always in x-axis, so minus B over 2A minus B over 2A over 2 times minus 1.5. So that is 3. It means that QM is 300. So Q max is 300. And the TR max, you can use again the formula B quadrat minus 4AC over minus 4A, or just fill in the 300 into this. Okay, I think I'm going to use, which one will I use? Well, the same. Let me do this. B quadrat, what is B again? 900 quadrat minus 4 minus 1.5. So 135,000. So this is the maximum revenue. Okay, so this is also the solution from the slide that I have worked on before. Now, this exercise, yeah, this is the same. I need you to do it by yourself too, and take also the notes for your task. Okay. Oh, but remember now, this one is in Q position. Yeah, so I need you to change this, because we need the TR as a function of Q, not a P. Yeah, so change that to the P function first, not as this one. This one is the Q function. So this one is actually function of P. Yeah, so we need function of Q. So change the position, like this goes to the left first, so 0.5 P, and the Q goes to the right side, 700 minus Q. Then P is 700 over half minus Q over half. So that is, what's that? P 1400 minus Q over 2. No, oh sorry, 2Q. Yeah, Q over half is, yeah, 2Q. Check it again. Okay, so now you can start like what I did before. Okay, so now let's go to the break-even point. Break-even analysis, a concept used to analyze the minimum number of products that must be produced or sold for a company to avoid losses. The break-even point, or zero profit, occurs when revenue equal with the cost. The company does not make a profit but also doesn't incur a loss. So graphically, this is shown by the intersection between curve R and curve C. So remember that the curve R is always downward concave. So this one is R, and this one is the T cost, total cost. Now if they crossing each other, so it has 2 points over here. So the point is at Q4 and at Q1. Okay, so at Q1 you see that the cost is over here and the revenue, and also here Q2 R2. So this is comma, yeah? So actually in one axis you can mention about the cost and also the revenue, because it has the same unit which is monetary unit. Okay, Q1 and Q4. Now you see here that the production levels of Q1 and Q4 reflect the break-even point, as total revenue equals with total cost. And the area to the left of Q1 and to the right of Q4 reflects a loss situation. Yeah, as you can see here, I put back the picture. And the area to the left of Q1 and the right of the Q4 here, reflecting the loss. So this one is the loss. This one is the loss between the curve. Okay. The what is that again? Yeah, so this mean that the R smaller than T cost. Meanwhile, the area between Q1 and Q4 reflects a profit situation, as total revenue is greater than total expenditure. So you see here that the line of revenue is upper the cost line. And the production level Q3 reflects the level of production that which has a maximum total revenue here, and the size of the profit is reflected by the magnitude of the positive difference between R and C. Maximum profit does not always occur when R is maximum or C is minimum. Yes. So you see here that it's not always like that. The gap, what matter is the gap between point of R and the C at the same Q. So if you see here, when revenue reach the maximum point, it has a smaller, yeah, through just a visual, yeah, we need um, to find out the exact distance between this line. So that's why it is very important to find what is the maximum profit, yeah, by making another function, yeah. So you have TR function as a function of Q, and also TC as the function of Q. Then you make a profit to see what is happening inside the profit, which give the maximum one. At the end, the profit is the last thing that we need to, not last thing, the first thing that we need to find out. So this will be TR minus TC function. Okay, so from here we will find what is the P maximum. Oh, example, total revenue obtained by a company is represented by equation TR 0.1 minus, well, I change that again into black. TR is minus 0.1 q quadrat plus 20q, while the total cost incurred is 0.25 q 3 q cubic 3q quadrat plus 7q plus 20. So calculate the profit of the company if 10 and 20 units of goods are produced and sold. So what is P when Q is 10, and what is P? I say that P10 and this is P20 when the Q is 20. So this one is the question, and this one is the given information. Now define first what is the profit function. Yeah, define profit function. Okay, the profit function is TR minus TC. You have TR minus 0.1 q quadrat plus 20q minus, now do a brackets here if you see the minus in front of the function, 0.25 q3 minus 3q quadrat plus 7q plus 20. Now then P will become, wait, I will erase the yeah, okay, then it will be minus 0.1 q quadrat plus 20q. Now open the brackets, minus 0.25 q cubic minus time minus plus q 3q quadrat minus times plus is minus 7q minus times plus is minus 20. Now collect for each variable. So you have here a cubic q3, then q quadrat is minus 0.1 with 3q quadrat, then it will gives you plus 2.9 q quadrat. 20 minus 7 is plus 13q minus 20. Now this is our profit function, and then you just fill in the 10 and fill in the 20 to this q here, then you will find out what is the answer of that. So I will do the 10 and the rest is u. Yeah, so if q is 10, then the profit will be minus 0.25 q cubic is 10 cubic plus 2.9 10 quadrat 10 2 plus 13 times 10 minus 20. So it will give you 25 times 1000 plus 2.9 times 100 plus 130 minus 20. It is 150. Yeah, I think it is 150. So check it again, okay, and do for profit at Q20. So the last example question is the total revenue obtained by a company represented by the function of R minus 0.1 q quadrat plus 300q, while the total cost incurred is 0.3 q quadrat minus 720q plus 600,000. Calculate the level of production that generates maximum total revenue. So this is A. B, the level of production that shows minimum total cost. C, which is better for the company, producing profitability at the level of production that generates maximum total revenue or minimum total cost. Okay. So okay, I have written this actually. So I will reading the slide. Yeah. Okay. Given that the revenue is minus 0.1 q quadrat plus 300 q, C is 0.3 q quadrat minus 720 q plus 600,000. R maximum occurs at, again remember that the R maximum, each maximum or minimum point will comes from minus b over 2a and ym. Yeah, I said this is x, b quadrat minus 4ac over minus 4a. So the q here always in the x-axis, remember that. Then the qr maximum. So again, this is the a here is minus 0.1, so it is smaller than 0. It will give a curve like this, so it is really a maximum point that the revenue will reach. And here is the a bigger than 0, so the curve will be concave upward. It has a minimum point, so it is true minimum and maximum. So every time, even though that the question will ask you about whether it is maximum or minimum, you need to check it first. Yeah, so that will give you an extra point if at the problems turns out it is the opposite of the question. Okay, got it? Right. So q maximum at r maximum, so I will rewrite this here, q at the r max, okay, equal with minus b over 2a. B is 300, so minus 300 over 2 times minus 0.1 is minus 0.2, then it gives 1500 unit. And C minimum occurs at, so QTC minimum minus B over 2A also, but with this equation, yeah. So we have here the B. So minus B is minus 720 over 2 times 0.3, and it gives 1200 unit. Then after you get this Q, you check it again to the profit function. So the profit here is R minus cos minus 0.1 Q quadrat plus 300 Q minus 0.3 Q quadrat minus 720 Q plus 600,000, and it gives you minus 0.1 Q quadrat plus 300 Q minus 0.3 quadrat, open the brackets, yeah, plus 720 Q minus 600,000. Okay, so that is, I hope I can still write here. Collect all the same exponential, minus 1, 0.1, and minus 0.3 q quadrat, the same q, plus 300 and plus 720. Okay, and minus 600,000. So you have, I will write here, okay. The profit function will be minus 0.4 q quadrat plus 1, 10, 20 q minus 600,000. Okay. Okay, now for the extra question, I will give another problems. So both TR maximum and cost minimum will give the same profit. So what is it is a C or a D? Well, let's consider that as a D. What is the profit maximum then? And the E, draw the function, all functions. Okay, for D, answer. So from the previous profit function, we have an A as minus 0.4, B is 1020, and C is, if I'm not mistaken, it is 600,000, yeah, 600,000. So P max, remember P is the Y position, so B quadrat minus 4AC over minus 4A. Okay, I will Q, yeah, Q first, erase, oops, sorry. Okay, so what is the Q at P max? Q at P max, yeah, minus B over 2A. This minus 1020 over 2 minus 0.4. So Q at P max is 1275 units. Okay, and the TR max is we just fill into the function, or with, okay, then just do with the function, yeah, B quadrat minus 4AC over minus 4A. So B quadrat 1020 quadrat minus 4 times minus 0.4 times 600,000 over minus 4 times a minus 0.4. So this is positive, okay. TR, I got not TR, yeah, P max, I'm sorry, it should be P max, yes. So 10,020 square 4 times 0.4 times 6 exponential 5 is 960,000 over, oh, this one is plus, yeah, because minus 4 times minus 0.4, and this is the same, 1.6. Okay, so it will gives you 20 quadrat plus 960,000 over 1.6. So that is 250, yeah. So let me check again, so you guys also checking it out with me, okay? Plus 960 over 1.6, yes, that's correct. So you see here, yeah, compared to the P from the R max and minimum, it is far away from them. So profit maximum will be reached at Q 1275 units, and the nominal of profit will be What's that again? 250 monetary units. Okay. Right. Now I need you to do the drawing all the functions. I give you the clue. So first of all, draw TR and then TC. Yeah. You don't have to draw the function, the profit function. Just draw the TR and the TC. Okay, and it should be give you a things like this. Yeah, this one is TR and TC. Um, and then you see this is the break-even point. So you just need the break-even point first, and then you will have a TR maximum at, what is that again, 300,000 if I'm not mistaken. And this one is how many Qs, I forgot. And here the minimum, yeah, things like that. Yeah, not the 300, this is a profit one, no. So just draw the TR and the TC. You don't have to draw the P. I will do that later. Okay, so this is your exercise. End of part 3.